Hello everybody and welcome to this tutorial how to model a snow sled in Shapr3D. In this video I will show you how to use a 3D scan as a dimensional blueprint. Further, this time I will focus on modeling by using all the already created sketches. As you can see, everything inside this file is named and sorted, which will make it very easy for you to jump right into it. This scan was created by using the new LiDAR scanner, which comes with the new iPad Pros and iPhones, and using the free app 3D Scanner app. What is very nice about this technique, besides being built in right into the iPad, is that the LiDAR scanner is instantly and very fast. The downside is, as you can see, the mesh quality is rather coarse, but everything is to scale. And honestly, when all you want is just to quickly digitize a bigger object so you have a proportional scale reference, then this is perfect. We can export this via STL and then place and import it into Shapr. Here you see the file where I just have the scan and a reference sketch under it. To bring in the scan, we can go to Import, Files, and then select your STL object. We will import it via meters. And there we have it. You see here, imported has 227 objects. That's way too much. This also includes all the scan fragments, but all I want is actually just this object. So I can move this one out, and then this folder we delete. Now we have to rotate this one. I also turned all the snapping off, so it makes it a little bit easier now to position everything. So you can see the top is a little bit rotated. So maybe 2 degrees. If I look from the front, the bottom is a little bit off, so maybe 2 degrees. We can use the grid to line everything up. What about the front or the left? Is this rotated this way or the other way? And this is basically how you then can reposition your scan. And to help with the positioning, that is the reason why I created the sketch. This one gives me a top and bottom border, a left and right border. Particularly here on the left, you see there's a nice line, and I can make sure that the edges of my mesh are also parallel to that line. I also have here these small distance lines, which I can move around and then see on top and bottom, does this actually line up? And the more these elements line up, the more then your scan is perfectly rotated. So we'll take a moment to position this correctly, but then this is a fabulous way to have a 3D scan, which we can then scan over. Model over. So with the scan positioned, we can now take a look at how I created the individual sketches. So I could then create the final CAD model. Before we take a look at the sketches, let's study our scan object. From the top, when we look at it, what do we see? Straight lines left and right. There is an arc, top and bottom, and inside there are straight lines. So it's actually very good to keep in mind. From here we can see the bottom is rather flat, the back is flat, it slightly arcs down, and then the top or the front goes up a little bit, is arced, and this point's a tick higher than there. So, if we take a look at our sketches, what do I have here? So from the side, I have sketches that define the properties I just highlighted. And from the front, I have here 3 sketches. When I select them and love them, they create this arced surface on top, and at the bottom, this is linear. So I will hide this one moment because I want to go back to here and explain something. You see here, these corner points I'm highlighting, they're all lined up. Just here, they are different. The way how I modeled this was I selected or made one sketch, and then I made a copy of the sketch, moved it to where I needed it, and selected one point and moved it. But it was important that the other points never got changed. So here we love this. There we are. Oh, I have this already. So let's remove one. And then we go to here and extrude this one out. So I have 2 surfaces or shapes, defining the side and defining the top. How do I find now the resulting shape? I can simply select both objects and then go to intersect. And there we are. Now from the top or the bottom, I have what I need, and also from the side. Very good. Let's go to this view. What is actually very interesting to point out at this moment is, you see I only work in a half object. Also all the sketches are just only defining half of the object. The design is symmetrical, so why should I make the sketches that describe the left and the right side? I can later, after I finish half a model, simply mirror it over. Easy. It's just effective working. Further, what's pretty cool about shelling in Shapr is I can select also curved surfaces and then shell it. There. Wonderful. But before we do the shelling, we have to do a lot of more work and also round edges. So we go backwards. I will start with this edge. Round this by 50 and round this by 20. You can actually click and drag the arrow for the fillet, or you with the pencil tap the arrow and then it gives you a value. Pretty cool. Okay, so I know we can shell it, so I will leave it where it is right now. Not going to do anything else. Let's go back to the sketch, and you see here I have a small profile. So this spline was actually offset by 3 millimeters, this line 2, so I create this strip on top. Why did I do this? In my scan you can see that here, here and there we have a small even lip that goes around it, and then here we have a bigger one. I'm going to show you now how easy it is to create that shape. So I turn on the sketches, select the profile, and then I extrude this a little bit more than I need. So from here to here, we have a distance of, let's say 2 centimeters. I will explain in a moment how I made that sketch too. This here we will extrude by 2 centimeters, so 20 millimeters. That was very easy. This line is also linear, so this face I only needed to extend by 2 centimeters. Now from the top, that's maybe a little bit more difficult because this is curved. So this sketch, which you see here, I created by selecting this edge. Then I went to More and Project and simply tapped on the grid. That then selects the ground plane and it projects the edge of my geometry into a sketch. And there we have it. Now this projected curve is a little bit too detailed for my taste, so I redrew it cleanly. To draw this more accurately, what I simply did was I selected this, made myself an offset for 2 centimeters. Then I had a perfect template, and with a new control spline, then I redrew a shape and tried to match it as closely as possible. I added some lines left and right at the center, so I could then create a profile, extrude, and when it intersects, it trims it. Very nice. Let's throw this away. And there you see we have now here and here, there and there, an even lip. The front we need more, maybe say 80 I mean. Looks too much. 50, 40. This is good, yeah. Perfect. Then we can fillet this corner. Same here. And I try to match it, not too big, not too small. So it looks pretty good and parallel, so that this arc and this arc feel like offsets. Selecting both objects, we join them. Very nice. Here's another pretty cool thing to show. I select both, go to shell, 3 millimeter, and it shells it. This shelling, however, can be a very complicated task. I mean, shelling is mathematically very complicated, so the cleaner the input geometry, the better. Here you can see that the result creates an interesting face. To prevent this, I simply shell this by 3.1. There. So now here to here, this has 3 millimeters, and then there to there, this is 3.1 millimeter. For the injection molding, this is not really a big problem. Very nice. So that looks actually pretty good. However, well, this is also the process how you always go forward and backwards. When we go back, and you can't see this in the scan, but the real object has actually these tracks. So that's a little bit of a tricky problem to put back in when we cut actually this opening. Then we have to go back and undo this. It's also good when you model to always maybe sometimes make a copy of your design and move it away. So should something go wrong, we always have a backup file. Let's take a look at how we can create the track. I created a construction plane just from here, and I moved it a little bit backwards, right to where kind of like I need to have this track. And you see then there I redrew also the lines from my side profile, but instead of being perfectly parallel, this curve goes in a little bit at the end, so here and also there. And then at the center of my sketch from here I drew a circle, because what I can do now is the following. I simply select this circle, then I select these three elements and say sweep. Very good. Now let's take a look at what we have there. From here, this is now very good to see. So there the surface goes back into the sled, and also here it goes back. And there you see, this is actually getting very, very close. So it took a little bit of figuring out how to draw this profile, which I have highlighted here right now. Technically speaking, what I'm talking about is where to position this point. Because the goal was to make an extrusion where the end stays inside the sled. Okay, good. This is the center part. I will make a copy and move this one up. Then a double tap, go to mirror across the sketch or the plane, make a mirror copy. So we can take a look at this, and inside the sketches. So this one we need at this point now to make a mirror too. And we can join all the objects. And now I can shell it. Look at that, it even shells the track. How awesome is that? For stability reason, this lip which we created, we want to fold down here a little bit, also there. So the whole construction will be a tick more stable. Also there I developed a neat trick to create this sweep surface and still end up with very clean surfaces. Here I have a sketch that actually defines that surface I need, and then I have another surface or profile which I will sweep to. So let's go ahead and we will select this. Notice that here you see the profile top left corner lines up with this edge. So we'll the whole profile. And say sweep. Very good. Now you might ask yourself, why is this at an angle? Why is this not horizontal? The main reason is if this would be horizontal, like this, I will turn on also my cut section view now, and I go to there. It might actually penetrate there just a little bit. So there you see where this point is. Oh, I have to stop tapping so quickly on the screen. Sorry for this. So let's go back. So if this would be horizontal, then there would be the edge, which then would be above the surface just a little bit. The other problem now we see is when we zoom in, there's a little bit of an overlap. This is all okay. That is the reason why I created this other rectangle. So these two objects I will join. Very nice. And let's go back to the sketch here. I will select this. This is now my cleanup profile. And sweep this around. Careful that you only select the correct edges. Very good. And then from this, I would like this surface to be subtracted. So think about this as a knife that kind of like cleans up the outside, or a piece of sandpaper. There we are, look at that. Nice and clean. As I like to say, very good. So, a little bit of filleting now. That's the last thing to finish most of these tasks. 2 millimeters. This looks good. So 2 millimeters plus 3 millimeters thickness means that this should be 5 millimeter. Here, here, here. Those we could all set to 2 millimeters. 5. Can make this bigger if we want to. So then 5 plus 3 would be 8 on the opposite side. So here, there, there, and there. 8 millimeters. The reason why I'm calculating inside and outside radius is, now you need to keep in mind, when this is the outside radius plus the material thickness, which is 3, or in this case, outside radius minus material thickness, will result into the inner radius. So that's the reason why I did this calculation. Cool. The last object that is left is this opening for my hands. And I just made one sketch, positioned it somewhere so it doesn't confuse me, or it's easy to move around. Then I rotate this so it will be more or less perpendicular on the surface. Also here, to work symmetrical, we do a mirror, and then from this we subtract those two objects. This takes a moment to calculate. This is also a little tip now. So you see that the calculation takes a little bit. The main reason for that is all the fillets I added. So ideally what I should have done first is maybe add a fillet, like all those I added it here. But when I'm not really done yet, I should have removed them. So when I then go ahead and do these calculations, it's faster for the software to calculate. And that's simply because the fillets add more surfaces. Makes everything more computational intensive. I will select those 4 edges here. The material thickness is 3 millimeters. We want to fillet it at least 1.5 millimeters. See if this works. This would make a nice and round fillet. Could also go 1.2. So it's a rounded edge with a small flat strip in the inside. And there we have it, a very nice CAD model of a very fast snow sled.